In this example, we're asked to use the formula for z to find the standard deviation from the following information. So we have the population mean, which is 100, we have a raw score of 140, and we have the z-score that corresponds to that raw score, and it's a z-score of 2. Now the formula for z that they're talking about is the one that we've been using, so it's z equals to a raw score minus the population mean over the population standard deviation. Normally what you would do here is you would use all of this information, so your raw score, your mean, your standard deviation, you would plug them in, and then you would get a value for z. But of course we've already got our value for z. What we're missing is the standard deviation. So we need to take this formula and rearrange it so that it looks like this. We've got the population standard deviation all by itself, and then everything else is going to be over here on the other side in some sort of arrangement. The way that that arrangement is going to look depends on what happens when we adjust this formula. And we're going to adjust this using our rules of algebra. Essentially, I want to be able to get the standard deviation all by itself on one side of the equation, and to do that I can perform two basic operations. The first is to undo any operation that I don't like that I see here. Like for example, we're dividing by the standard deviation. I don't want to be dividing by the standard deviation. I want the standard deviation to be on the top or by itself. So to undo any operation, we have to perform the opposite operation. So if you see something being divided, just multiply by that same element. If you see something being subtracted, just add that same element. The trick though is you have to do this not just you can't just follow this one rule, you have to follow a second rule as well. You must perform the same operations to both sides of the equation. So for example, I'm going to start here by multiplying this side by sigma. So these will cancel each other out. So that will stop me dividing by sigma. But I have to perform the same operation to this side as well. So when I rewrite my equation, it's going to be z sigma equals x minus the mean. So now what I have is sigma almost by itself in the right spot. But I've got it being multiplied by this z here, and I don't want to see that. So I go back to this first rule here to undo any operation. So multiplying z by z, I want to undo that. I perform the opposite operation. So I'm going to divide by z, but I have to do the same thing to both sides. These two will cancel, and that's going to leave me with sigma equals to x minus the mean over z. So this is the formula that I can use to find sigma. And so now I can simply just plug in the values that I've got over here. So I've got my raw score is 140 minus the mean of 100 over a z-score of 2. And so this gives me 40 over 2. And that gives me 20. So my standard deviation is equals to 20.